What's the link between software and your health? Hi, my name is Oded, and in this podcast I'll talk about software development in the field of medical device, pharmaceutical, and healthcare with industry-leading experts. In this episode, we'll see what BDD is and examine if it can provide answers to failures encountered in medical device development. I'm very happy to present the distinguished Mr. John Ferguson Smart, the man who has become synonymous with behavioral-driven development. Hi John, thank you for participating. Can you please tell us a bit about yourself and your background in software development and Agile?
Yeah, sure. It's a pleasure to be here. So I'm an technical Agile coach. I've been working in software for over 3 decades. So one of my specialities is getting teams to communicate more effectively and getting them to articulate their requirements in a format that can be automated. And often we call that behavior-driven development. So I think that's what we'll be talking about today. I also do a lot of other sort of coaching and training. So I run a thing called the Serenity Dojo, which is a training and mentoring program for testers wanting to get up to speed with test automation and who want to really become excellent in agile test automation. So yeah, that's a little bit about myself.
And maybe we can start by you telling us also what is BDD and what the problem that it tries to address?
Yeah, sure. So traditionally, what happens in software development is we have sort of like a game of Chinese whispers where the product owner or the customer will tell the BA what they want. The BA will write the requirements up in some form, be it a requirement specification document or a user story in Jira. That gets given or presented or handed off to developers who go away and build something. Testers write test cases based on the requirements and then go and test the solution that the developers built. And each time you have this handoff, this disconnect between what was originally asked for, what was understood, what was actually needed, and what ends up being delivered. And that sort of disconnect accumulates, and that's where we get defects and errors and misaligned solutions. And so what behavior-driven development is it's a collaborative approach where rather than trying to hand off the requirements at each stage, we sit down together with product owners, with customers, with BAs, with developers, with testers. Everyone gets together and sits down and walks through the requirements, walks through the goals, what you're trying to achieve, and explores what you don't know, because all these assumptions and all this uncertainty that's sort of hidden in traditional requirements is what trips you up further down the line. And so in BDD, what we try and do is we have structured conversations to try and get to the bottom of what a requirement is supposed to do, what it's about, what are the edge cases that might happen, what are the sort of weird things that might crop up, whether we fully understand what we really need to do. And then we feed that back to the customer, to the product owner, to make sure that everyone is happy with it. And then what's really cool is the requirements or the format that we put those requirements in, we can turn it into a structured notation, which we can then automate. And we call that, the idea of that is called executable specifications. And so effectively, in a well-tuned BDD project, your specifications become your automated tests, and your automated tests are your specifications. And you can even take that further, because at each level, you'll start off with high-level specifications, which you have high-level automated tests. And then as you drill down, you'll get more towards a TDD approach where you have unit tests, which are actually specifications for lower level code. So it permeates right through the system, and it's extremely effective at improving quality and reducing defects if people do it in a disciplined way.
You described the BDD environment where the ownership of creating the right requirements doesn't fall only on the business analyst or the software analyst, but instead it's more of a shared responsibility, right?
Absolutely. Yeah,
So
absolutely.
I can see the benefits for the at the organization level, but if I'm playing a little bit devil's advocate, I can think that maybe the developer or the tester might not see the incentives, because now when that's a shared responsibility, if they got the requirements right and they bring low value, they're not off the hook. Before they can say, oh, I just developed what I was asked, and the tester say, yeah, just check that it meets the requirements. So it kind of requires them a kind of emotional labor. Is it a real issue in the industry?
I find it's an issue in very traditional teams, teams that are used to being told what to do, or teams that are used to handoffs and not having to think too much. So it's not usually a big deal in teams that are getting into an agile mindset. It's more of an issue where a team is still thinking in very waterfall mentality, and if that's the problem you're coming across, then that's generally a bigger, broader problem of agile adoption and sort of modern development practices, modern development mindsets. Because if you're still in that sort of handoff mentality, it's going to be very hard to be competitive or very hard to produce high quality software. And I mean, we see even today there's software released all the time, so that's massively overrun. The UK government at the moment, it's notorious for it. It's got massive overruns of budgets, software that doesn't work well, software, and it's all to do with this concept of, oh, we write some specifications, we hand it off, we give it, and then it's not our problem. We'll just build what we were told to build. If you've got to really try and get beyond that, and that's sort of not just BDD. BDD is just one facet of that, and BDD really brings to the table techniques that highlight problems or highlight issues of communication. If, for example, in a BDD approach, what we try and do is we have these conversations before a sprint starts or before a cycle starts, and we have these conversations to come up with these executable specifications quite early on. But if a team is still starting stories and they know very well that some of the stories have not been specified, or some of the stories have not been discussed, but they take them on board anyway with these sort of loose, roughly defined requirements on the grounds that, oh, well, we'll just do what's written down and it won't really be our problem, then that's a bit of an unhealthy team culture that you really need to address on a sort of a broader context, if that makes sense.
Yes, absolutely. And you describe now BDD as part of that agile mindset. I mean, I know that agile is about accepting the uncertainty that exists in software development projects. How does the BDD address this requirement uncertainty that we face at the beginning of projects?
BDD is about recognizing that you won't know everything right up front. So writing great big specifications up front is very hard and generally doesn't work. And even if it did work, you get the problem of you don't get the buy-in. So you can write a requirement. That doesn't mean the developers will understand it. So what BDD does is it gives us techniques to really explore the uncertainty and flush out what we don't know. And so we have techniques. A lot of BDD is actually communication techniques and facilitation techniques, and that's what's often overlooked when we talk about behavior-driven development, but it's a really big part. So there are facilitation techniques like example mapping and feature mapping and just using tables and whiteboards. And there are all sorts of techniques that we use to make the communication process a lot more rigorous and a lot more predictable so that we can explore the uncertainty. So one of the principles is that when a story comes to the table, we don't assume that it's correct. We don't assume that everything is there, and we don't assume that you can just understand it correctly by reading it. We kind of, like you were saying earlier, we play devil's advocate. We try and say, well, if that's the case, what about this? Or what could happen here? Or what if this edge case occurs? And you try and flush out all those aspects of those that could cause uncertainty later on. So it's really not about the product owner or the customer presenting a user story and saying, this is what you need to build. It's about the development team, developers and testers, proving to the BA or customer that they've understood what they need to build.
Right. If I understand what you're saying, you're kind of taking it further. You're saying also the BA the business analyst, he can't say the customer asked me to do that. They kind of have to discuss why did the customer ask for that requirement, what business needs it needs to meet. Is it fair to say?
A common situation is where a customer will ask something like, well, I need this button on this form. And in a traditional approach, a BA will say, right, that's the requirement. I'll write a story given I'm on this page when or as a user, I want to see this button on this page. But in a BDD context, we'll say, well, why do you want the button? What's the actual business outcome you're trying to achieve there? And that's not BDD. That's actually, that's just good agile practices, but it's very prominent in BDD. We go out of our way to make sure we understand what the purpose of a particular requirement is, where it's coming from, and so that we can actually understand the best way to provide the optimal solution to that requirement. Because often customers and business have a tendency to solutionize too early, and they solutionize from their point of view. They may not have the ideal solution in their minds. So there's a big exercise in facilitation to try and make get to the bottom of what the business owner, what the product owner, what the business actually wants, what they actually need, and what their real goals are, and then articulating that in a way that you can find an optimal solution, or more than one solution, and compare them.
Right, I see. And so does that data play a role in understanding customer usage and closing the gap between the product hypothesis and the business impact in BDD?
So BDD is I sort of treat it as being fairly broad. And so often we think of BDD as, it's just test automation with Cucumber, but it's actually way more than that. And it also merges into practices like impact mapping and story mapping and event storming and all these sort of high-level requirements, discovery value stream mapping. All these high-level discovery practices flow very well, sort of seamlessly into a BDD approach, where pirate canvases is another good one. So all of these techniques are about discovering the high-level hypotheses and discovering what the real goals and the real outcomes are, how you could measure the impact of those outcomes, and then what features would support those outcomes. And then from the features, you go into a more detailed discussion about what are the acceptance criteria for those features. So it's a seamless process going from your high-level activities like impact mapping or pirate canvases or story mapping down into the more detailed activities like feature mapping and example mapping. So there's all these techniques that you use at different points in the life cycle to try and understand different facets of the requirements.
Okay, but is there any stage in the life cycle that really verified the impact that the user had?
On the other side, that wouldn't be technically BDD. I'd say that is more impact mapping. What we do is we identify the hypothesis, we identify the metrics, what dials you're trying to move, and identify how you're going to measure that. Now, I would say that that's borderline on the fringes of BDD but I include it in the overall process, because to decide whether a feature is actually worth building and whether a feature was worth building, you've got to measure the outcomes. So in the BDD in Action book, which the second edition, there's a diagram which shows a big circle, a big cycle, and the outer side, it's actually several concentric loops. The outer loop is what happens when you speculate about what features or what capabilities are going to deliver the value that you want. And then once you've cycled through several sprints or several iterations and you get to something that you can measure, then you validate whether your speculation was correct. You validate whether the capability or the features that you've built actually deliver that value. And then you feed that back into the next process. So it's the concept of using hypotheses and defining what you measure and then measuring that and getting the feedback is in the sort of broader life cycle of BDD.
Okay, so I can understand from your description how BDD helps with the higher level requirements, like to make sure that they really provide value to the user. But what about those unit testing that really help us write clean code that kind of make our code more testable and more solid.
When you do BDD well, ideally what you do is it's called outside-in development. So if you're, for instance, imagine you're building a microservice for some service, and what you will do is you'll have those conversations, you'll define what the high-level acceptance criteria are, the business-facing acceptance criteria, you'll map them out in an executable format, and then that gives you the starting point and the ending point for your development. And then at each point as you go down, you'll have one acceptance criteria which will fan out into a number of low-level requirements. Now, those low-level requirements might be things like, well, we've got this piece of data coming in. What if it's null? What if it's an invalid value? And so forth. Business don't care about that because it's technical. But from a developer point of view, you do care about it. So you write a low-level specification saying, well, if this value is in this particular format, it's valid. But if it's in this format, it's invalid. And here's what we do about it. That happens at a unit testing level. And we write that. If you're using a BDD approach, often you'll use a BDD style of writing your unit tests. And effectively, it's a good way of doing TDD. It's TDD done well is another way of expressing it when you get into the code, because you end up writing very low-level specifications for your APIs, and not that low-level, but low-level detailed specifications for your classes and your modules, your web services, your persistence layers, whatever you need to implement. You end up having specifications at the appropriate level in the form of unit tests. And the cool thing is, since they are written as specifications and not as unit tests, a unit test is you write a test and it tests what the class does. A low-level specification, you describe what the class should do and then you implement the class. And that makes a huge difference because when you describe what the class should do, you don't commit to an implementation. So you don't tie yourself to a particular implementation of the class. Whereas when you test what the class does, often you will tie your test to how it's been implemented, and that makes the test much more brittle. So when you use a BDD outside-in approach and you practice TDD in the same style, you end up with very, very readable tests and also an optimal number of tests. You don't get too many tests. The tests don't get fragile. You don't get tests that are tied to the implementation. And the tests document what the code does really well, so it makes maintenance a lot easier. So when you see a code base that's been written that way, it's really a pleasure to work with. Because basically the tests are the documentation.
That's really sound like state of the art. And okay. So I understand it's kind of, when you start at BDD, it takes you to TDD in a way, like TDD done right, as you said. So it's kind of pushing you toward that. So that's excellent. I wanted to ask you something different, a little bit about maybe comparing now to the 90s. What shifts do you see in the role and responsibility of the tester? And is there still value in managing the testing task by a dedicated test specialist? Because I know some leading organizations have stopped using testers. So
I think there's still a specialist role, just like there's a specialist role for different developer roles. I still find it valuable to have someone who has a role of specialist tester or specialist test automation engineer, because test automation engineer just is quite specialized. It's just like there are specialized roles that I might be very good at working with NoSQL databases or I don't know, that's some other specific technical layer, but I might not be so good at working with Oracle. There are different specialities that you might have as a developer. It's the same thing with testing. It can be a speciality. Even if a developer is perfectly capable of writing automation, that doesn't mean you can't have people who are specialized in knowing how to do it very well. So I think there is value in that. The other difference with the roles are, if you go back to, say, the 80s or the 90s, you'd have, we were waterfall, we were sort of V model, where you'd write up your test plans, you'd write up your even write unit test plans, integration test plans. You'd have user acceptance tests that derive from the requirements. You'd write up all these detailed plans, and then you'd go away and test them afterwards. And the plans would be so detailed because potentially you could hand them off to someone else, even in another organization. And that's extremely expensive to write those sort of test plans. And there's always the possibility of getting the disconnect between them. It's also very labor intensive. Nowadays, in agile projects, the role of the tester is much more embedded in the teams, and it becomes much more a role of a quality coach and a role that is not only about testing the finished product, but testing the requirements as they come in. So a good tester in an agile project can act as a gatekeeper, not only to prevent bad features going out because there are defects in them, but also bad requirements coming in because they haven't been analyzed enough and there isn't clarity on what needs to be built. So you get that sort of QA role going right through the process, not just at the end. I think that's one of the biggest differences.
If I understand what you're saying modern QA is more about kind of critical thinking and less about writing test scripts that check that a given requirement was made. Is that
what I find is that the best teams when it comes to the automation were the best teams collaborate on the actual automation side of things. So maybe it'll be the tester doing some of the automation. Maybe it'll be, I know a lot of UI developers who love doing the front end automation, and it's sort of just a duck to water type thing. It's really very fluid, but there's value in the testers collaborating on specifying exactly how you're going to express those requirements and how you're going to turn the executable specifications into an executable format. You'll have developers who will be able to automate how you interact with web services, how you interact with back-end systems very effectively, and also at the same time design the system so that they can be testable, so that you can trigger a workflow process effectively, or so that you can inject test data effectively. When you get that collaboration, it works really well. If it's just the tester doing it, it's less efficient. It takes more time. So there's a lot of value in developers participating in the automation, but often what happens is that you'll have experienced testers or agile software developers in test, more experienced agile test automation engineers who will know the sort of best practices that you do to guide that. So in a way, I see them acting as coaches and sort of, I don't want to use the word architects, but yeah, coaches and the leaders of the automation initiative, and so that they can basically guide the teams, guide the developers into helping make that automation work effectively. So they'll do some of it themselves, and hopefully the developers will do some themselves as well.
Okay, but so I understand. So what would you say? I know that's less common today because TDD kind of made testing cool for developers, but you can still hear developers thinking that testing for testers, and on the one side, that's the problem on the one side, and on the other side, you see that testers are really keen to get into automation, but they kind of, because it's kind of end-to-end UI testing, you see things like with Selenium, and that you get yourself into a real trouble as an organization where you heavily automated through the UI. Do you understand what I mean?
Yes, so that is the bane of Cucumber is when it's used as an automation UI tool or UI automation tool. It's really, really horrible. We don't want that sort of automation script because they're hard to maintain, and they're lots heavy UI-centric automation, which is the natural tendency of a lot of testers because that's where they come from. The first automation we had was UI automation, but they're in an agile project. It does where it works best. I mean, I've got working with a team at the moment. They can run 1,500 business-facing acceptance criteria, automated acceptance criteria, in about 15 minutes because they collaborate tightly together to make that work. So you could never do that with UI testing. So the collaboration really pays off, but it does take some sort of coaching and some influence and some explaining and even just sitting down and doing it. A good approach that I like is if the developers have doubts, well, you just sit down and do it and make it work and show them. And then they say, oh, yeah, finally it does work. It's not that hard, because automation code is not actually that hard. It's just you have to think to do it well and think to factor it in early. So really the important thing is getting the developers wanting to be involved early. That can be a challenge, but it's like Kent Beck once said, I can write software much faster if it doesn't have to work.
That's funny, yeah. Okay. I see your point. And you don't necessarily think that kind of automation is also programming, and you kind of need a high level of programming skills to be involved with that and really understand that yes, this needs to go to at the UI level at the end, and this needs to go down to the unit test and should not be tested at the higher level. You don't think you think that QA can go through that transition from being a manual tester to that level of expertise?
I would say I've seen many manual testers take that journey. It's not something you can do in a 1-week course. It's not something you can do just by reading a book or two. It does take effort and time and dedication to learn to do automation properly, because like you say, it is coding. It's specialized coding. It's a narrow branch of coding, but it does needs all the same quality aspects of code as production code. You can't just write rubbish test scripts and expect it to be maintainable. You do need to be able to have conversations with the developers to say, well, there's no point writing a UI test for this requirement because it could very well be tested at the unit testing level, and we're fine with that. So you need to be able to have those conversations and understand those. And so the testers do need to be able to understand or be confident that the unit tests do the proper job. So it's a tester who is purely manual will take a bit of learning to get up to speed with automation. There's no doubt about that. But it is a journey that I've seen many testers do. So it's more. There's a lot of testers are afraid of coding. They're afraid of getting into sort of anything beyond scripting, and that holds them back. There are genuinely some people who are more have a more sort of, how would I say, they've got a better aptitude for exploratory testing or manual testing or coaching or then the more technical coding. But a lot of testers are perfectly capable of getting into automation and doing very high quality automation code. As soon as they get past that fear, even if it's a subconscious fear, but that fear of actually doing real coding and not simply staying at a level of scripting.
Okay, I think that's very comprehensive. I wanted to ask you also, where does the GUI designs that we used to see, where do they fit in, or the UML diagrams? Do they have a place in the BDD mindset?
It's probably more a question about, do they have a place in Agile? I don't see a lot of UML these days, but I do see domain diagrams quite often. That's and it's also a TDD question, because in TDD, often what you'll do is you will try and drive your code from the code, but for your design from the code, from the tests, but that doesn't mean you can't draw up a diagram because it expresses ideas more clearly or gives you a bit more clarity about the picture you're trying to represent and the model you're trying to do. So it just becomes more informal. Same thing with UI design. There is an anti-pattern of coming up with a great big detailed UI design before and separately to the development process and just giving it to the developers and have them build it. It's where UI design works better.
That sounds familiar.
Yes, it's often the case, because UI is still a little bit separate, and even your design thinking, it's still a little bit separate from development. But where it works really well is, like, if you take, say, story mapping or feature mapping, these are techniques where you have a lot of, you're talking about user journeys through the system. And like feature mapping, you'll be talking about the steps that a user undertakes to achieve a particular goal. There is clearly input from that into the user experience. And there's clearly input that the user experience people can put into that to say, well, those two steps should actually be together, or these two steps, that one step is actually two steps because of these constraints, or wouldn't it make more sense if we flipped these two steps around? There's a lot of user experience that can come into sort of mapping out those flows. And so it's really good to have UX people involved in those conversations, which happen relatively early, but not like 3 months before the project starts. And so it's sort of, then the trick is you've got to be able to do, say, story mapping or feature mapping at a high level, say a couple of sprints ahead, so that the UX people do have time, if they have to do the designs, whatever designs they want to do. And then without having to basically set the design in stone before you have any conversations about the actual features that you're trying to build.
Right. But we can't keep that benefit of BDD that you have a single source of truth. Then with those GUI designs, of course, it has to be maintained separately, right?
BDD is more, the single source of truth is more about the business rules and the high-level flows. It's not about particular buttons. You don't want to see buttons or clicking or fields inside a BDD scenario into an executable specification. That'd be too brittle. So the screens and the UI design are an implementation of the rules that the BDD scenarios explain or document. So, for example, your BDD scenario might explain how you calculate sales tax on when you check something out of or sales tax and postage when you check out something in your shopping cart, whereas the UI design will actually say where the buttons go and so forth.
I see. So we are reaching the end. So a big question before the end. What if I have an existing application? The code is really written beautifully. There's no issue with that, but there's no unit testing, no automation, not even proper documentation. How would you advise to maintain it BDD wise if you want to incorporate it?
That's a really good question. We come across that quite often. And what you don't want to do is try and retrofit a whole lot of BDD scenarios to an existing application. Sometimes when it's a really important piece of software and there is a lot of movement or there will be maintenance and it needs to be documented, what I advise to people to do is to write basically BDD scenarios and features around the key flows to basically document the system in a BDD way, as opposed to trying to say, okay, we'll test every single screen. So you basically do a brainstorming session, say, okay, what are the 3 most important things this piece of software does? And then those 3 most important things, you break them down. Let's talk about the flows and the edge. What are the key flows? What are the edge cases? Let's document them and see if we can write some BDD scenarios around them and then see how we might automate them. That's assuming that there's going to be churn and there's value in automating them, because if there's no churn and it works fine, then there's probably going to be little value in automating them.
Right. But if really doing the bare minimum just to kind of make this infrastructure in place, is that correct?
Yeah, pretty much. I mean, even the high-level BDD scenarios don't cover a huge amount of the details. They're not for test coverage. They're more for documentation. The test coverage comes from the TDD unit tests, and you would not want to retrofit unit tests to an existing application. That's very time-consuming and a very thankless task, and it's quite hard to do because often the code is just not designed for testability. So you only do that if you're intervening in a piece of code and you need to make a change to it. Then you can start to see how can you refactor this code to make it more testable, and there are patterns to do that, but you don't want to do it wholesale for the whole application.
Right. Thank you for that insight. So maybe you can tell us to close, how can people follow your publication? You mentioned the book as well. So maybe you can tell us a bit about.
So the second edition of BDD in Action is in, it's in the Me app, which is the beta version on Manning at the moment. I publish a lot of stuff regularly on LinkedIn. So one of the best ways to see what I'm doing is to follow what I'm doing on LinkedIn. And if you're interested in the Serenity Dojo program, I assume there'll be a link later on, but if you type serenitydojo.com, you'll find something about it as well.
That's brilliant. Thank you so much. It's very generous of you to take the time and share your knowledge with the community.
You're most welcome.